In orbit, there are no explosions, only a vibration rippling through metal like the heartbeat of a dying machine. A tiny grain of metal moving at 7.8 kilometers per second can tear through a billion-dollar satellite in a fraction of a millisecond. So, could humanity ever armor a satellite, turning it into a true warrior of space? In this video, we'll explore why satellites in orbit are far more fragile than you might imagine.
We have green
The
across the
bold
board,
human
ma'am.
attempts to create space armor, from metals and composites to magnetic fields and plasma shields. And finally, which technologies might allow satellites to survive the orbital battlefield of the near future. This isn't just a story about engineering. It's a story about human intelligence fighting for survival in the silent void of space. 2. Stay until the end, because every detail in this video will change how you see humanity's next battleground, the sky above us. If you love advanced military technology and future warfare concepts, give this video a like, subscribe, and share. It really helps fuel more deep dive content like this. Before we talk about armor, let's look at the harshest battlefield we've ever entered: space. Up there, there's no air, no sound, and nowhere to hide. Temperatures swing from negative 150 degrees Celsius in darkness to plus 120 degrees Celsius under the sun. But the real killer is speed. Every object in orbit travels faster than a rifle bullet, about 7.8 kilometers per second. Even a speck of paint, lighter than a grain of sand, can rip a billion-dollar satellite apart in a fraction of a millisecond.
We need to reinforce
In such a place, armor no longer means what it does on Earth. Because up here, there are no small collisions. Every impact is catastrophic. Most satellites are paper thin compared to the machines we built for war. Their walls are just a few millimeters thick, enough to block radiation, not enough to block destruction. And that leads to the paradox of space defense. The safer you try to make a satellite, the heavier it becomes. But the heavier it is, the harder it is to launch. So the real question isn't, how do we armor satellites? It's, can armor itself survive in space? In the next part, we'll uncover the first daring and often disastrous attempts to make space armor a reality. When the question, can we armor satellites, was first asked, scientists
If we angle the
didn't sit
pressurized
still.
like this,
Back in the 1950s, one man, Fred Whipple, an astronomer working with NASA, came up with the first idea of space armor. His creation, the Whipple Shield, used a brilliant two-layer design: the outer skin to shatter incoming debris, the inner wall to absorb what's left. That concept has saved hundreds of satellites. Even the International Space Station relies on it today.
the Whipple Shields
But
are
against
fully
anything
pressurized
larger
and ready
than a
for
pebble,
deployment sequence.
it fails
Outstanding work,
completely.
gentlemen. Project
Every
Swift ought
extra
to be a
millimeter of
resounding
armor
success.
means
The shielding
tons
held
of
up
added
perfectly.
mass.
Look at the telemetry.
During the 1980s, as the
energy
Cold War
absorption
pushed
matches the
humanity
projection
into the
exactly.
weaponization of orbit, both the US and the Soviet Union experimented with titanium-armored satellites. Every prototype failed, not because of physics, but because of weight and cost. Some even tried exotic alloys like Inconel or ceramic titanium. But these supermetals turned into dead weight in space. 1 centimeter of plating could add over 3 tons, costing hundreds of millions in launch expenses. Reality set in fast. In space, strength isn't survival, efficiency is. After those failures, engineers began asking a different question. Not, how do we make armor harder, but how do we make armor smarter? In the next part, we'll explore that transformation, from brute metal to reactive materials, composite skins,
simulation
and
shows a
electromagnetic
40%
shields
reduction in
as
mass.
humanity redefines what armor means in
maintaining
space.
full
After decades of failure, humanity realized
Activation
something
sequence
fundamental.
complete. All
Armor
green.
doesn't need to be harder, it needs to be smarter. That's when the age of reactive materials began. Engineers at Lockheed Martin and DARPA developed a new type of protective skin, the reactive Whipple layer, using nano-titanium particles mixed with aerogel. When struck at hypervelocity, those particles instantly solidify, self-sealing the wound and dispersing kinetic energy, much like blood clotting after an injury. At the same time, research groups in Japan and Europe experimented with adaptive composites, materials that could change density within milliseconds, hard when threatened, flexible when safe. Armor, once just metal and mass, was becoming something alive, a responsive system that could sense,
the kinetic
adapt,
dampening
and
field
survive.
is stable.
But the frontier pushed even further. Scientists began exploring plasma shields, magnetic barriers, and even electromagnetic deflection fields capable of bending debris away. It sounds like science fiction, but inside classified U.S. Space Force labs, these ideas are being tested right now. Now, armor doesn't just endure. It reacts, it learns, it fights back. In the next part, we'll witness that transformation, when satellites stop being targets and start becoming weapons in orbit. For decades, satellites were passive, silent observers circling above, watching wars unfold below. But that silence is ending. Today, satellites are learning to defend themselves and, quietly, to fight. Projects like Starlink Defense Network and the U.S. Space Force's Guardian Shield initiative are rewriting what armor means. These are not shields made of metal. They're systems of awareness, reaction, and counteraction. Some satellites now carry micro-thrusters, capable of dodging debris or even anti-satellite missiles in real time. Others are wrapped in stealth coatings that absorb radar and thermal signatures, making them invisible in orbit. A few experimental models go further: directed energy satellites, machines that can project laser pulses to disrupt incoming projectiles or blind sensors. Think about that for a second. The same sky that once connected our phones and GPS could, one day soon, host autonomous machines waging silent duels in orbit. And honestly, that thought chills me, because while I admire the ingenuity, there's a part of me that wonders, what happens when defense turns into offense? When the armor starts aiming back?
Status update on the incoming
Space was meant to unite us, a frontier of discovery, not destruction.
All available defense
Yet
satellites.
here we are, building weapons to protect our dreams among the stars. Maybe that's what progress looks like. Fragile, conflicted, unstoppable. But make no mistake, the race has already begun. In the next part, we'll step back and look at what this all means, not just for technology, but for humanity itself. Because the future of armor in space isn't about metal, it's about who we become when we build it. When we first asked, can satellites be armored? It sounded like a question about metal and technology. But after this journey, through failures, breakthroughs, and silent battles in orbit, I think it's really a question about ourselves. Because every time humanity builds armor, it's not just to protect machines, it's to protect our hope. Hope that our creations will survive. Hope that progress can exist without fear. Hope that even in the cold silence of space, something human still remains. The truth is, yes, we can armor satellites. But the stronger question is, should we? If every invention becomes a weapon, where does exploration end and war begin?
Look at the energy dissipation.
I don't have the perfect answer. Maybe none of us do.
It stabilized the kinetic
But what
impact.
I believe,
The
and what
plating
I've
works.
learned from studying this, is that progress isn't just about what we can build, it's about what we choose to build for. Space armor, in the end, isn't just steel or plasma. It's a mirror. a reflection of our fears, our brilliance, and our stubborn will to survive. And maybe that's what makes us human. If this story made you think, if it gave you a new way to see the future, hit that like button, subscribe, and share this with someone who loves technology and stories about where we're heading. Because the next episode, we'll dive even deeper into how the next war might begin in orbit and how it could be stopped before it ever reaches Earth. Until then, keep looking up. The sky above us is no longer silent. It's speaking, and we're just starting to listen.